All right, guys, here we go. We're going to do a series of videos that goes over the midterm review for Algebra 2. So you can follow along here, check out the rest of my videos on the page to help you guys get ready for your midterm. All right, I'm going to start with the first one. So the first one has a few parts where it asks us to evaluate and then simplify if possible. So the first one says f of c minus 2. So how I'm going to do this is where it says x in my function, I'm going to replace that with c minus 2. So c minus 2 squared plus 2 times c minus 2, and then minus 3. Now I'm going to expand this binomial that's squared. We've done this a few times in class. If you do not know how to do this quickly, please write c minus 2 twice in FOIL. But you square the first one, so that's c squared. You do the first one times the second one times 2, all right, which is going to be negative 4c. And the last term is the negative 2 squared, which is plus 4. All right, distribute the 2, you get 2c minus 4. Bring down the minus 3, and now it's all about doing combining like terms. So I have c squared, negative 4c plus 2c is minus 2c. 4 minus 4 becomes 0, so we just have minus 3. All right, now this is technically factorable, but like we talked about recently in class, if we're not asked to do anything with this, there's no reason to factor it. All right, you can if you want, it's not wrong, but I'm going to leave it in this standard form. Okay, let's do B. B says to find x when the function g of x is 57. So I need to replace g of x to be 57. So I'm going to write x plus 5 squared minus 7 equals, and they're asking me to make it equal to 57. Now I've seen some students do this in class where they're expanding the binomial squared, right? Similar to what we did in part A. But my brain is thinking this has become a quadratic equation that I'm going to solve using the square root method, right? When I see this in parentheses, right, isolated for my square right here, that tells me that I'm going to use the square root method. That's my preference. Now, it's not wrong if you do the other way. It'll just take you a lot longer. Okay, so I'm going to add 7 to both sides to get 64. Take the square root of both sides, so that gives me x plus 5 equals plus or minus 8. Now remember, like we've done before, if you have this perfect square of 64, please continue to simplify. So I have negative 5 plus or minus 8, so I'm going to have two answers. X equals negative 5 plus 8, which is 3, or x equals negative 5 minus 8, which is negative 13. Okay, let's go to C. C, we're using the h of x function, and I'm plugging in negative 10. So it equals 5 over negative 10 plus 10. Now that's going to be 5 over 0, which is going to be undefined. Cannot divide by 0. So h of negative 10 is not able to be defined. All right, last part on this one says find x when f of x equals 4. So very similar to letter B, but this time I'm doing f of x. So let's just write f of x real quick. That is x squared plus 2x minus 3. All right, I'm going to set it equal to 4. Now my first thought is this is a quadratic equation, so I want to set it equal to 0. I'm hoping that I'll be able to factor. Moving that 4 over with subtraction makes negative 7. But unfortunately, when I check to see if it is factorable, right, I have a times c, which is negative 7, and b is 2. There are no factors of negative 7 that are going to add to 2. So now you've got options. The way that my brain sees this is I look in front of my squared term. A is 1, right? I look at my b term. B term is even, so I am going to complete the square. Now, some of you out there will do the quadratic formula. That's fine, but I'm going to complete the square. So I'm going to write x squared plus 2x, leave a space, equals positive 7. When I move it over, I need to find b over 2 squared, which is going to be 2 over 2 squared, or 1 squared, which is 1. So I'm adding 1 to both sides. This is going to be x squared plus 2x plus 1 equals 8. completing the square allows me to factor this perfect square trinomial to be x plus 1, all of that squared. Now it becomes the square root method. So I have x plus 1 equals plus or minus the square root of 8. All right, so I'm going to write my answer as x equals -1 plus or minus, and the square root of 8 simplified is 2 times the square root of 2. All right, and that is it for the first page. Okay, page 2. Page 2, we have this whole graph here, and I'm doing a lot of stuff with it. All right, this is our function g of x. So it says evaluate when g is -9. So I'm going to go over to -9 in the x value, and the y value is 4. G of 0. Go when x is 0. My y value is 3. G of -5. G of -5 is going to be 6. Okay, last one like this is g of 10. Go over to 10 in the x, that is 5. Now, E and F are going the other direction where I'm given y values, right? G of x equals 5 is really just another way of saying that y is 5. So what I do is I draw a horizontal line at y is 5. So like this. And I want to see where does that hit my function. So it's my function here. Hits that function here. Oops, sorry. All right, so that looks like x is roughly -5.5, or when x is 10. Let's do the same thing for +7. So go to +7, draw that horizontal line. Okay, and it looks like it's only hitting right. I think for this one, probably the key says that it's only hitting at -1, which is totally fine. It kind of looks like it's hitting before that, but we'll go ahead and say the highest point is 7. So we'll say when x is -1. But I could see if you drew that why you think it'd be more. Okay, domain. Now, we're moving from left to right, starting at -9, right, including it. We don't have any issues until we get to between -1 and 0. There is a break. So I'm going to include -1, but then I'm going to have a union. I'm including 0. But take a look at this open circle at 5. So I need to do parentheses, union, start again at 5, and go to 10. All right, including 10. For the range, my lowest y value is +1, but we're not including it, right, because it's open. And then it looks like we have overlap here, so the highest y value is 7, and we're including it. Is it a function? Yes, I don't have any issues with the vertical line test. Anytime I do a vertical line, I will hit 1 point, so yes, it passes the vertical line test. Okay. All right, now I'm going to move into doing some transformations with parent functions. All right, and looks like there's 3 of them. So I'm going to do these next 3 to finish out this video, and I'll call that part 1. All right, so this first part here, I always want to do the original parent function. In this case, it is the square root function. Feel free to write the words, or you can write f of x equals the square root of x, your call. All right, I'm going to go with my original points, which are, for square root, going to be the x values are 0, 1, 4, 9, and 16. So when I take the square root of those, I get 0, 1, 2, 3, 4. It is not necessary to graph the original. If you'd like, that's fine, but I'm not going to. I'm going to list the transformations. So I have this 2 in front, which is a vertical stretch by a factor of 2. I have this -1 inside, which is really going to be +1, so 1 to the right. And then I have this +3 outside, which is 3 up. So how I'm going to change my values is I'm going to do +1 for 1 to the right on my x values. And my y values are going to be that factor of 2 stretch, so times 2, and then add 3 for 3 up. So that's going to be 1, 2, 5, 10, 17. I won't be graphing 17. 2 times 0 is 2, or excuse me, 0 plus 3 is 3. 2 times 1 is 2, plus 3 is 5. That's 4, plus 3 is 7. That's 6 plus 3 is 9, and then 8 plus 3 is 11. Let's graph those. 1, 3, 2, 5, 5, 7, and then 10, 9 is my last one. No, hopefully you know at this point, if you don't, review it, right, how we're going to finish that graph. Right, it's not going both directions, just one direction. All right, great band. So the domain is not all real numbers, right? Not negative infinity to infinity, because we're not moving to the left or to the right forever. So our lowest x value is 1. We are including that. Our highest x value is infinity. Our lowest y value for the range is going to be 3, and our highest y value is infinity. And that is it for that one. Okay, next one. This one is a quadratic parent function, or x squared. My parent function values are -2, -1, 0, 1, 2 for x's. Square them for the y's. Take a look at the transformations here. We've got 4. We've got a vertical compression by 1/2. We've got a reflection, that's that negative, over the x-axis. And then we have 3 to the right, think opposite, and we have 4 down. All right, so let's change that. That's going to be x plus 3, and a lot going on with my y. I'm going to multiply it by -1/2, and then I'm going to subtract 4. So doing the x's, adding 3, that's 1, 2, 3, 4, 5. All right, half of 4 is 2. The opposite of that is -2. Minus 4 is -6. Half of 1 is half. So it's -0.5 minus 4 is -4.5. That's 0 minus 4 is -4. This one is also going to be -4.5. And last but not least, this one's going to be -6. All right, so plotting those, I get 1, -6, 2, -4.5, 3, -4, 4, -4.5, and 5, -6. Again, know how this works. This is a parabola. Excellent. So this one, I do have arrows going left and right forever. So my domain is -infinity to infinity. My range is -infinity. We're going down forever. My highest y value is -4, closing it. All right, last one for this part. All right, this is absolute value function. All right, again, you could write f of x equals the absolute value of x. Okay, my original points are the same x values as my quadratic, but they're all positive for the y's. Transformations, this one's more basic. I only have 2 transformations, 3 to the right, and then 2 down. So changing my values, that's going to be +3 for the x's and -2 for the y's. All right, so that's going to be 1, what is that, 2, 3, 4, 5, and subtracting 2 gives me 0, -1, -2, -1, 0. So plotting those, 1, 0, 2, -1, 3, -2, 4, -1, and 5, 0, making my v. Again, hopefully you remember that from our first unit. Domain is all real numbers. We're going left and right forever. But range is not. Our lowest y value is -2. We're touching that. Highest y value is infinity. All right, I'm going to pause here. I know that was already kind of a long video. So tune in for part 2.